Okay, so our next lesson, we're going to actually review some old algebra. Okay, so it's something that you may remember from last year, depending on who taught you algebra last year and if they did this type of factoring. But it is going to be very important for what we do when we continue with our equations of circles. So it's a form of factoring called completing the square. Okay, the nice thing about this, it actually works for all trinomials. So if you learn this, it's actually a way you can factor everything. So let's look at completing the square real quick. Where it comes from is a very simple thing like expanding a trinomial. So before we factor, let's start off with not factoring, the FOIL that you did. So I want you to take this trinomial or this binomial here. We've got this 5x minus 3 squared. And go ahead and expand that out, FOIL that out. So as you were FOILing that out, you probably remembered that, oh yeah, you have to rewrite this as two things. So I got to rewrite this as 5x minus 3 times 5x minus 3, which gives me 25x minus 15x minus another 15x plus 9. And that's just doing our FOIL. So that's 25x minus 30x plus 9. That's called expanding that out, or just basic multiplying. So what we want to do now is I want to look at one particular term of this. I want to look at this 30x. In fact, I don't even care about the plus minus in the middle, okay? Just looking at the 30. In fact, let's look at the number 30. The number 30 is really 2 times 15. That's how we got there. In fact, if you look, the reason that we got the 30 is because we have two 15s right there. So that's where that 30 came from. But 15 is nothing more than 5 times 3. And where did 5 and 3 come from? Well, the 5 was this first coefficient here. And the 3 was that coefficient there. So really, that 15, that middle term that we're talking about, oops, let me get my laser pointer. This middle term is really multiplying these two terms together and then multiplying by 2. That's how we get that middle term. Okay, and that's what we're going to be looking at doing to sort of make things work for us, which means that if I want to, I can sort of write a generalized idea that no matter, whoops, why won't you select that? There we go. No matter what the formula is, no matter how your trinomial is written, what a, b, and c are, this middle term will always be equal to 2 times a and c. So this middle term is always 2 times a times c, okay? Now, things get even easier if a, also known as the leading coefficient, for those of you that have forgotten, this is called the leading coefficient because it's the first coefficient when we write it. So that's our leading coefficient. Things get even easier if that leading coefficient is 1. Because if a is 1, then b is really 2 times 1 times c, which is really 2 times c, which makes life even easier for us. Okay? Which means that really the c term is b divided by 2. And all I did there to get that is I simply said, hey, if I divide both sides by 2, I get this thing here. And that's what we're going to be doing to make that c term work out for us, okay? There is a little bit difference so that I make it work in a perfect square binomial. Because what we're trying to do is get something, my Cami is freezing up on me, there we go. We're trying to get something that factors into this, okay? And that's called a perfect square trinomial. Perfect square trinomial is this trinomial. There's a 3-term thing, hence the trinomial, that when you factor it back becomes a binomial that is squared. Okay, so that again, that's a term from your algebra class that hopefully you remember. How can we make that happen? Well, let's talk about factoring first and why we even want to factor. One of the key reasons to factor is it allows us to solve for problems, okay? So like this problem here, if I factor this, I factor it in 2 separate parentheses, which we generally tend to do when we see trinomials. So 6, I can factor 6 as 3 times 2. And if I do a positive 3 and a negative 2, that gives me a positive 1 in the middle. Now, the whole idea of factoring is the law of multiplying by 0. If you take two things and multiply them to equal 0, one of them must be 0. That is just a fact of multiplying by 0. That's why we always want to set our things equal to 0 whenever we're factoring. Because if I want to multiply to make 2, there's an unlimited possibility. This is 1 times 2. There's 1/2 times 4. There's 1/4 times 8. Bunch of different possibilities to get 2. But to multiply to get 0, something has to be 0. So when I do that, it means that either x plus 3 has to equal 0 or x minus 2 has to equal 0. And if x plus 3 will equal 0, well, that'll happen when x is negative 3. And this will happen when x is 2. So there's your possible answers. That's one of the big reasons we like the factor. Another reason we like the factor is so that we can do what we're doing with our circles, and that's get things into that circle form. But again, we're not getting there yet. But what happens if I can't factor it as easily as I did that last problem? Like in this case, the only thing that multiplies to make 3 is 1 times 3, at least in whole numbers. And that's not going to give me a 6. So this is where completing the square comes in handy. So I've broken this down into basic steps of what you want to do to complete the square. So let's start with step 1. Step 1 says put all the variable terms on one side and all the constants on the other. So if I do that, the constant is the thing without a variable. So that's going to be x squared plus 6x on one side and negative 3 on the other. Why negative 3? Because I want to subtract 3 on both sides. Okay? So far, so good. So now that I've got all my variables to one side and the constant to the other side, I want to factor out my leading coefficient as long as it's not 1. Now, in this case, life got real easy for us because my leading coefficient is 1. Remember, if there's nothing written next to the x, then the coefficient is 1. So I don't have to do anything in this case. So in this case, my a equals 1. So I'm good. I can just rewrite this and be done with it so far. Okay, but we still haven't factored, right? We haven't done anything fancy with the factoring. I just moved something to the other side. That's not factoring. So now I need to find a new C term. Okay, now our C term is going to be found by doing this equation right here. Okay, so my C will equal whatever my B term is over 2 squared. This is also known as the square constant. Okay, because what we're doing is we're finding that constant and squaring it so we get a perfect square at the end of it. So my B term is the 6. Okay, so when I write this out, I'm going to leave a little space this time. I'm going to write x squared plus 6x equals negative 3. And what that B term is the 6. So I'm going to go off to the side and I'm going to go, well, C will equal 6 over 2 squared. 6 over 2 is 3. 3 squared is 9. And I'm going to take that 9 and I'm going to add it. We're always adding to both sides. Okay? Always adding. You don't even have to think about anything else. You're going to add that number to both sides. Now we can go ahead and factor because now I have a beautiful, easy to factor trinomial right there. Okay? Forget about that side. We don't care about that side. Ignore that side. We're just going to factor this. Okay, so when I factor that, I'm going to break it up as 2 sets of parentheses, x and x. Let's see, 9. Well, 3 times 3 is 9, and positive 3 plus positive 3 is 6 in the middle. And this other side, negative 3 plus 9 is 6. But look at what you've got here. You've got something times itself. Well, something times itself is squared. So I can rewrite this as x plus 3 squared equals 6. Now, in your algebra class, you may have gone ahead and solved for x here. Okay, square root both sides, subtract 3, boom, you've got your x. Okay, we don't care about that right now. Okay, that's not important to me. I want you to learn this process because we're going to need it for what we're doing in our next lesson. Okay, so let's look at another example and we'll try this process one more time. We're going to do a bunch of different examples and you're going to try some on your own as well. Okay, so the next example. First things first, get all my coefficients to one side, all my exponents, let's try it again. Get all my variables to one side and all my constants to the other. So my variable terms are x squared plus 10x, and my constant term, I'm going to move 24 over, so that becomes negative 24. Okay, so that's step one. Step two, find the c term. So c equals my b term, which is the 10. 10 over 2 squared. Well, 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25 to both sides. And now I'm ready to factor that. Okay, so I'm going to say x and x. By the way, this side just simplifies to 1. 25, well, that's 5 times 5 is 25. If I do positive 5 and positive 5, I get positive 10. So I can rewrite this as x plus 5 squared equals 1. And there we go. So now it's your turn. Try one here. X squared plus 6x minus 11 equals 0. Factor it. Okay, so hopefully your first step is that you moved everything around. X squared plus 6x equals 11. Then you said, let me get my c term, my constant square, or my square constant rather. So that's going to be 6 over 2 squared, which is 9. So I'm going to add 9 to both sides. 11 and 9, well, that's 20. That was easy. And now this side. Hey, you may have noticed a little shortcut with all of these. Notice what happens when I look at this term here. It's basically the square root of that every single time. So even when we did it up above, okay? So if I look up top here, let me see if I can get my little pointer back. When I look up here, there's my 3, which is the square root of 9. Okay, so every time that's a shortcut way to find that. That sort of makes our life a little easier because now I can just go, oh, so this is x plus, by the way, the sign always follows this sign, okay? Every time we use the sign here, it's going to follow that sign, so they link up. And in the square root of 9 is 3, and we square it. There's my factored solution. Simple as that. Let's try another. This time I need to start off the same way. So 2x squared minus 8x equals, add 7 to both sides. So that gives me a 5. But this time I don't have a leading coefficient of 1. So I need to factor the 2 out on just this side. I'm going to leave a little space here. Okay, so all I did is factored out 2 from the x squared and the 8x. Now I need to complete my square. So I get my square constant. So my middle term is 4. Forget the negative. We don't care about the negative. So 4 over 2 squared, which is 4. So I'm going to add 4 here. And I'm going to add, this is where you got to look out for it, 2 and 4. So I'm going to add 2 times 4. Okay, so look out. That's where that leading coefficient comes in handy and can sort of throw you off if you're not careful. The 2 is just going to hang on to the outside here. 2 times 4 is 8 plus 5 is 13. And this is my x squared. Square root of 4 is 2. Follow the b term sign. There you go. Oh yeah, don't forget to square it. And there's my solution. Okay, so the little things to look out for in this particular problem. Make sure that you factor out the leading coefficient, factor it out of both these terms, and then make sure on the other side, when you're putting it in, you multiply it back. You're using the exact same c term inside the parentheses. But when you're putting it on the other side, it's not just a 4, it's 2 times 4. So things should match up. You should have a 2 and a 2, a 4 and a 4. Okay. All right. Try one on your own now. Okay. Go through here and factor that one. So as you're factoring, start off by moving. Let's get a better color than that. That's hard to see. So we move our constant to the other side. So I'll subtract 5. That's going to give me a 1 on this side. I need to factor out my leading coefficient. Okay. Notice I left some space because I'm thinking ahead. I need to complete my square now. So I'm going to go complete my square. So C equals, and that's going to be 2 over 2 squared. 2 over 2 squared is 1, and 1 squared, there we go, is 1. So I'm going to add 1 here, and I'm going to add up. Be careful. It's not 1. It's 2 times 1. So now I've got 2x. Square root of 1 is 1. Follow the sign of your b term, minus. And then 2 times 1 is 2, plus 1 is 3. Okay, let's take a look at one more. And I tell you what, I think I'm going to switch these. Instead of doing the example, I'm going to do the try problem and have you do the example, okay? So let's look at this try problem here. Need to move things around. So what I'm going to do is I'm going to move the 6x over here, and I'm going to move the negative 1 over here. So that's going to be a 2x squared and a minus 6x. And when I move the negative 1, that's going to make it positive. And I just reflip the sides there because I like my constants on one side here. Okay, oops, I got a leading coefficient, so I need to take that out. Take out the 2. So that's x squared minus 3x equals 1. Excellent. So far, so good. I've gone through moving my x's. I've gone through getting out the coefficient. Now I need to find my square. So I go, let me get that square. My c term will equal 3 over 2 squared. 3 over 2 doesn't divide. So we just leave it as 3 over 2. And remember, whenever you square a fraction, you just square the numerator and square the denominator. So 9/4. So I'm adding 9/4 here. I'm adding 9/4 there. So my 2's on the outside. My x stays here. Hey, the square root of 9/4? You already know the square root of 9/4. Remember, that's going to go into this place. The square root of 9/4 is 3 over 2. You already dealt with that. So there we go. I'm going to put my 3 over 2 here, and my sign in the middle is minus. And now I've got to add that together. That's okay. I go over to my scrap paper here, and I say 1 is really 4 over 4. Remember, adding and subtracting fractions, you need common denominator. So 4 plus 9 is 13/4. There is my last part here. So yeah, you can do this with fractions too. Nothing fancy. Takes a little practice. Don't be afraid of fractions. Why don't you try the next problem? Go. So we're looking at this one. I'm going to do the same thing. I'm going to move over my coefficient or my variables. I have no ability to speak today, apparently. We're going to factor out the 4. That's going to leave me x squared minus 2x, leaving a little space. Okay. Ooh. Did you guys catch my mistake in the last problem? Let's go back and fix my mistake in the last problem. Because what did I forget to do? Hopefully you said you forgot to multiply that by 2. Okay. So really, let's get my eraser here and erase some things. What I'm really multiplying or adding to this thing is not 9/4, but we can call that, well, let's actually simplify that easier. That's going to be 18/4. So now I'm going to make a lot of this easier. My numbers just got way smaller. Let's get rid of all of that. Because 9/4 times 2 is 18/4, which reduces to 9/2. Now I'm going to add 1 to it, so I'm going to add 2/2. That gives me 11/2. Whew. Hopefully you saw that mistake and you're like, Mr. Cox, you made a mistake. And hopefully you didn't make the same mistake yourself. Because now when I go get my C term here, I have to 2 is my b, divided by 2 squared, which gives me 1. So I do plus 1 here, plus 4 times 1. That's the 4 and the 1. Okay, so be careful. If you did make that mistake, that's okay. Now is the time to make mistakes. We'll fix them when you get better. That's why we keep practicing. And we all make mistakes. We just try to minimize our mistakes as much as we can. So that's going to give me 5. And there is my answer. Okay. So watch out for those little mistakes like that. And that sort of cleans us up, gets everything done there. You've got a couple things to do. You've got a Google form, which looks long, but what you're doing on the Google form is 2 things. For every problem, you're first finding what that constant square is, okay? Then the next problem, you factor it into the factored form. So you do that on the Google form for all of them. And then there's a delta math. The first part of delta math is just finding that constant square, okay? The next part of delta math, the next problems, are factoring it into forms like this, okay? Once you get done with that, we'll be ready to use this for circles in our next lesson. Bye.